All right, welcome. Completing the square, part one. So this is the last thing that we have to learn in our Algebra of Quadratics series. So we've looked at all kinds of different ways to transform and to manipulate quadratic equations from the three different forms, standard, factored, and vertex. We're only missing one. And the one that we're missing is going from standard form to vertex form. This is completing the square. And once we have this, we have all the other tools that we need to be able to play with quadratic formulas and answer quadratic problems no matter what form we're given in order to find either the y-intercept, the vertex, the factored form, or to solve using either factored form or vertex form. So today's going to be a pretty quick lesson. We're not going to go through completing the square completely, but we are going to go through how to find the value of c that will complete the square or create a perfect square trinomial. Now, we already know how to complete the square, sort of. We know how to complete the square in very special cases. The case is when we have a perfect square trinomial. When we have a perfect square trinomial, the factored form and vertex form are actually exactly the same. So let's take this first one on the left here, for example. So this is y is equal to x squared plus 8x plus 16. And this meets the conditions for our perfect square. The coefficient a is a perfect square, it's 1. The square root of 1 is 1. The constant c is a perfect square, 16 square rooted is 4. And 8 meets that special criteria we talked about where it's the square root of c times 2, or the square root of c plus itself. And we'll discuss that in this lesson in a lot more detail, but first, let's just do what we know how to do. We've been factoring enough now that it's probably drilled into your heads. So I know this is going to be x, and I'm looking for two numbers that add to 8 and multiply to 16. Well, that's going to be 4 and 4. And because this is a perfect square trinomial, that means that we end up with two identical binomials, and the proper form to write that would be x plus 4 squared. That's it. And that's either factored form. We could call this factored form because it's really just y is equal to x plus 4, where my roots are -4, and there's only one root, which means it must be the vertex. So the vertex is going to be at -4, somewhere like that. Or this could be factored form where the vertex is, this could be vertex form where the vertex is really 0, and so we didn't write it in. And that would make sense because if the vertex is right on the x-axis, then that will be the point -4 and 0. So the vertex would be -4 and 0. All right, cool. So we're like halfway there. We already sort of know how to complete the square. The only thing we need to do is we need to talk about cases to complete the square where the y value of the vertex is not 0. So let's explore the same thing, but let's just do it backwards. So let's do the distribution first. So this is x minus 3 squared. This is a quadratic. It's either plus 0, or we could say it's in factored form, but let's say it's in vertex form. So let's just say that we know the y value of the vertex is 0 and the x value of the vertex is positive 3. I'm going to expand this out or write it in expanded form, x minus 3, and I'm going to distribute. So x times x is going to give me x squared, x times -3 is -3x, -3x again, and then -3 times -3 is positive 9. And simplify this by collecting like terms. -3 minus 3x is going to give me -6x plus 9. And take special care as to where this middle term came from. This middle term came from -3 plus -3, or -3 minus 3, it's the same thing. So -3 plus -3, but where did those come from? So these 3's here added to give us this middle term, but they multiplied to give us this 9. So let's now look at a case where I'm missing the c value. I want to know where the C value came from. This is the skill that we're going to need to complete the square. We're going to need to know how to find a missing C value in order to make this a perfect square trinomial. Which means I need to look at the relationship between this middle term and this last term. Well, I know that that middle term came from two numbers that add to that, and this is those same two numbers but multiplied to something. So it's two numbers, they're going to add to 2 and multiply to this magical thing. Now, this thing, if this is going to be a perfect square trinomial, it has to be a perfect square, which means it's got to be a number times itself. So I already have some clues about what these need to be. These need to be the same number. It's got to be a number plus itself and a number times itself is basically where we're at. So what number plus itself gives me 2? Well, 1 and 1. Those are the only really two that work. So if 1 plus 1 gives me 2, then 1 times 1 gives me 1. So this number here must be 1. So this is positive 1. All right, let's try that again. So here's x squared minus 6x plus c. I want to find the value of c that will make this a perfect square trinomial. Okay, so I know that -6 comes from two numbers that when added together gives me -6. But because I want this to be a perfect square trinomial, I know they also have to multiply to that mysterious c term, but they have to be the same value. So really, instead of writing a number times itself, I can write it's got to be that number squared is equal to something. So what number when added to itself is equal to -6? And another way of writing a number added to itself is multiplying a number by 2, right? 3 plus 3 is 6. 2 times 3 is 6. So I'm really just multiplying the number by 2. So I'm looking for a value when multiplied by 2 gives me -6, and when squared gives me the c term. Well, what number when multiplied 2? It's -3. And so this is going to be -3 too. And so my mysterious number is 9 is the value that's going to complete the square. So this is going to be 9. And let's check to see if that works. So let's see if we can factor this. So x, and they shift factors into two identical binomials if I did successfully create a perfect square trinomial. So this is going to be x, this is going to be x. Two numbers that add to -3 and multiply to +9, that is -3. And so I got x minus 3 squared. Perfect. This was a perfect square trinomial. It works. A trick, if we want to work backwards, so it's really a number. If I start here, to get this value, all I'm really doing is I'm taking this b value, I'm taking -6, and let me rewrite what we had. So I was looking for a number that when multiplied by 2 gave me -6, but when squared gave me the number I was looking for. So if I'm working backwards, if I start with this number here, I'm looking for a number that, so 6, so -6 divided by 2, because I'm looking for this number. So I'm looking for this number, is -6 divided by 2 gets me that number, and then that number squared gets me my c term. So it's my b value divided by 2. And then whatever I get for that squared will give me my c term that will create a perfect square trinomial. So let's try that system out. Let's try it out down here. Actually, let's do this one second. Oops. Do that next. Let's do an easier one first. Let's do another one, x squared plus an x plus something. I'm looking for this value that completes the square. I just gave you a shortcut, which is c is equal to the b term divided by 2, and then the whole thing squared. Well, my b term is 10. So c is equal to 10 over 2 squared, which is equal to 10 divided by 2 is 5, so it's going to be 5 squared, which is equal to 25. So what is my c value? So my c value is 25. Does that work? This is a perfect square, that's a perfect square, and this is half of c, or sorry, the square root of c times 2. And that works. And if I were to factor this, it would be x plus 5 squared. And let's do the exact same thing, but over here. So here we're going to end up with a fraction, which is going to make it a little trickier. But I want to look for the c value. So it's going to be half the b value squared. Well, in this case, half the b value, because b is 5, half the b value is going to be 5 over 2. And let's keep that as a fraction. So 5 over 2, if I want to square this whole thing, I need to distribute this power into both the numerator and denominator. So it's going to be 5 squared and 2 squared. I'm going to get 25 over 4. And can I reduce that? 25 is divisible by 5. It is not divisible by 4, so we're going to keep it as 25 over 4. And what will be the factored form? Well, it's x plus 5 over 2, because that would be the square root of 25 over 4. And that's pretty much up for today. That's all you need for today's lesson and today's worksheet. Tomorrow we're going to use this skill and to actually complete the square for trinomials for which the vertex doesn't have a y value of 0. It is something else. But have a good day. If you have any questions, please let me know or drop me a line or message me in Google Classroom, and I will see you tomorrow.